Okay, so let's go ahead and look at the identities part on the review. So we have 23, which says cosine of x minus secant of x quantity squared is equal to tangent squared of x minus sine squared of x. So if we look very carefully, this whole thing is being squared, so I can rewrite this 2 times. So cosine of x minus secant of x times cosine of x minus secant of x. Now here, I'm just going to go ahead and FOIL. So if we FOIL this, cosine of x times cosine of x is cosine squared of x. Cosine of x times negative secant of x is negative cosine of x times secant of x. And then negative secant of x times cosine of x is negative secant of x times cosine of x. And then negative secant of x times negative secant of x is a positive secant squared of x. Now, our goal is to match the right-hand side of this equation. So we need to get tangent squared of x minus sine squared of x. If we look closely here, we have negative cosine of x times secant of x and negative secant of x times cosine of x. Well, cosine of x and secant of x, they're reciprocals of each other. So if you multiply those trig functions together, they give you 1. So here we have cosine squared of x minus 1 plus secant squared of x. Now, what would happen if I make cosine squared of x something else? Let's go ahead and recall our Pythagorean identity. So that is what? Cosine squared of x plus sine squared of x is equal to 1. And I want to solve for cosine squared of x, right? So if I were to subtract both sides by sine squared of x, well, cosine squared of x is equal to 1 minus sine squared of x. So I can replace cosine squared of x with this. So I'm replacing this with 1 minus sine squared of x minus 1 minus 1. And then here we have secant squared of x. Well, if you remember, so let's say I divide everything by cosine squared of x. Okay, so cosine squared of x divided by cosine squared of x is 1. Positive sine squared of x divided by cosine squared of x is tangent squared of x. And then 1 over cosine squared of x is secant squared of x. Well, what I'm trying to do is, since secant squared of x is equal to that, well, let's go ahead and replace secant squared of x with 1 plus tangent squared of x. Now, I can go ahead and look at what we have here. So 1 minus 1, they'll cancel each other out. And then negative 1 plus 1, they'll cancel each other out. So what am I left with? I have negative sine squared of x plus tangent squared of x, which I can rewrite as tangent squared of x minus sine squared of x, which is exactly what's on the left-hand side. All right, number 24, we have cosine squared of b minus sine squared of b. We want to get 2 cosine squared of b minus 1. So you might trial and error this, but this is how I'm going to approach this. Now, I notice that we are dealing with, the exponent of 2, right? So cosine squared of b and sine squared of b. So perhaps we can work with this by using our Pythagorean identity, which is sine squared of b plus cosine squared of b equals 1. Or if you want, you can just write cosine squared of b plus sine squared of b equals 1. It's basically the same thing. Now, let's go ahead and solve for sine squared of b. And if I were to get sine square root of b by itself, then it's 1 minus cosine square root of b. So what I'm going to do is replace sine square root of b with this expression. So cosine square root of b minus, now I don't want you to put 1 minus cosine square root of b like that. You need to put parentheses whenever you see a minus sign like that. Okay, so it's minus sign, and this is the trig function you're replacing with this expression. So please make sure that you put parentheses around the expression. Okay, so what do we do here? Well, I can distribute the negative to each term. So I have cosine square root of b minus 1 plus cosine square root of b. Now look at that. We have two of them, so I can say 2 cosine square root of b minus 1, which is exactly the right-hand side. Number 25, we have secant to the fourth of theta minus tangent to the fourth of theta, and our goal is to get 1 plus 2 tangent squared of theta. Now, this is a difference of two squares, so we can go ahead and write our expressions where one of them has a plus and the other is a minus. So this is going to be secant squared of theta plus tangent squared of theta times secant squared of theta minus tangent squared of theta. And I'm going to differentiate my pluses and t's, okay? So again, we have secant squared of theta plus tangent squared of theta times secant squared of theta minus tangent squared of theta. Now, what I'm going to do, because we need to get 1 plus 2 tangent squared of theta, is let's replace the secant squared of thetas so that we can get, tangent involved. Well, if we recall, right, so here's my Pythagorean identity. If I were to divide everything by cosine squared of theta, I get tangent squared of theta plus 1 equals 1 over cosine squared of theta is secant squared of theta, right? So this is what happens when I divide the Pythagorean identity by cosine squared of theta for each term, right? So now these secant squared of thetas I can go ahead and replace. I get tangent squared of theta plus 1 plus tangent squared of theta times, okay, well, that secant squared of theta is now tangent squared of theta plus 1 minus tangent squared of theta. Now, if we look over here, tangent squared of theta minus tangent squared of theta, they'll go away. They cancel each other out. So we have tangent squared of theta plus 1 plus tangent squared of theta times 1. So we're just left with tangent squared of theta plus 1 plus tangent squared of theta. And how many tangent squared of thetas do we have? Well, we have 2. So 2 tangent squared of thetas plus 1, and that equals the right-hand side. Number 26. Okay, so we need to get cotangent squared of theta. Okay, well, I notice that this is one term and this is my other term. we can factor a cosine squared of theta out, and we're left with 1 plus cotangent squared of theta equals the right-hand side. I'm going to go ahead and rewrite the Pythagorean identity. So I wrote sine squared of theta plus cosine squared of theta equals 1. Let's go with cosine squared of theta plus sine squared of theta equals 1. These are the same thing. It's just that the cosine squared of theta is first, right? Doesn't even matter. Now, let's divide everything by sine squared of theta. So you're left with, well, cosine squared of theta divided by sine squared of theta is cotangent squared of theta plus 1, and then 1 over sine squared of theta is cosecant squared of theta, right? 1 over sine squared of theta, the reciprocal of that is cosecant squared of theta. Okay, so what does this all mean? Well, I can replace this 1 plus cotangent squared of theta with cosecant squared of theta, right? I could write 1 plus cotangent squared of theta or cotangent squared of theta plus 1. It doesn't really matter. It's the same thing. So in this case, it's cosine squared of theta times cosecant squared of theta. And we all know that cosecant squared of theta is 1 over sine squared of theta, right? Cosecant squared of theta is 1 sine squared of theta. And I'm going to be multiplying that by cosine squared of theta. So if I multiply these two, I get cosine squared of theta over sine squared of theta, which we all know is cotangent squared of theta. Right? We said that cosine squared of theta over sine squared of theta is cotangent squared of theta, which is exactly what we want as it appears on the right-hand side.